Welcome to the Fundamentals of GIS lecture. We will cover scale, map projection, and design. So if we consider this concept of map scale as a mathematical function, where you have map distance in the top and earth distance at the bottom, whenever there's greater earth distance covered on the map per inch, for instance, we have what's called a smaller scale map. This is unintuitive to many, including myself, because we're showing more area on the map, but it's considered a smaller scale map. On the other end of the spectrum, 1 inch on the map is covering less inch on the ground, or less space on the ground. Perhaps 1 inch is only 1 mile, whereas on a smaller scale map, 1 inch is 100 miles. As you can see in the graphic again on the right, we're looking at more detail, but it's covering less area. So this idea is fundamental to GIS and mapping. And with static maps and even online maps, we use these scales to consider how much area is shown on the map. The second fundamental concept is projections. So, for the most part, the Earth is round, or it's a spherical shaped object. We live in a three-dimensional world, but maps are two-dimensional. So this is a two-dimensional sheet of transparent paper, but also a map. So how do we get from this to this? Is called projection, which is a mathematical operation again. And the way in which we project this to this does cause compromise, because we're losing essentially a dimension of detail. And so the types of map projections that we will see, though you don't need to memorize them for the purpose of this class, it is important to know that anytime you project a three-dimensional object to a two-dimensional representation, you're going to lose some detail. So if we go with just the planar projection, the idea is we're projecting this three-dimensional object to a plane. And at that point on the plane, so here we go, is a common Mercator projection. That point is the most accurate representation, and as we move away from that point, we lose some detail, and that detail could be shapes, distance, area. There's a number of projections called conic projections, and this looks like a cone, right? Put it on my head. We put that on a sphere, and with this conic projection, the most accurate spot is the point where the two-dimensional plane is touching the sphere, and then we have compromise going out from out. These are necessary compromises in mapping. And actually, this is the Mercator projection. The planar one wasn't the Mercator. This is the famous Mercator projection, which is called a cylindrical projection. So we have a cylinder wrapped around the globe. And so this is the idea behind map projections. Okay. Now, when we're projecting, we lose some accuracy. And to help grapple with that idea, we have what's called ground control points. And specific ground control points have been collected and literally mounted into the ground and recorded for, surveyors and engineers to use, and cartographers to use as a way to maintain the accuracy in mapping. And so we see here on this slide in the bottom right, one of those survey markers, which informs what are called datums, which are essentially known accuracy control points that are associated to projections. So we can use these different datums along with projections to create the most accurate map whenever we're going from that 3-dimensional to 2-dimensional space. And so within this idea of projections, we should mention states use what's called the state plane system, which is just one application of projections. In North Carolina, they use the Lambert conformal projection based on the 1886 spheroid, or 1866, I should say, and that's codified in legislature. And that's kind of like the official system for North Carolina. And Florida, as you can see, has 3 different projections they're using for their state plane system. And so it's often dependent on the shape of the state, actually. Moving on, this part of the lab or module, we will get in this part of the class in this module, we will get into this idea of map design, but we'll continue to talk about this throughout the semester. But this is just introducing you to the idea that when we design maps and we choose projections and scale and symbology, which is just a fancy way of saying the features that represent, the features we use to represent the features on the ground. So the map features that represent the features on the ground, we may have a point representing police stations. So that point is a proxy for a police station on the map. That's a symbology choice. These choices should be considered in terms of use, right? And in the disaster management cycle, we may go through this iterative process that the textbook lays this out pretty well, where we consider like the audience and how we're going to represent it. And then we may even go through a process of getting feedback, like you put out a set of like evacuation zone map, and then you get some feedback that, hey, that's not clear. You know, it's not clear to us citizens or residents where the evacuation zone is. So maybe the map is modified. And on this idea, I like to also bring in McEachran's cartography cube, which is a sort of standard way to think about map making. I think it's very useful to consider that maps are made by different agencies and groups and individuals even for different purposes. And that purpose should guide your design. And McEachran, he's a cartographer up at Penn State who did his dissertation on this, and he's very well published in this area, developed this cube as a way to like think about map use. And I love it. I think it's great. So on one end, it has like it's a cube, so it's 3-dimensional, but it has like different, dimensions across which to consider the map use. So it may be a public map, or it may be a private map, or maybe somewhere in between. But if it's a private map, you can put certain things on the map that you wouldn't put on a public map, and vice versa. Similar with this idea of being static or interactive. Is it an online map where people can click on things, even submit things, or zoom in and out? Or is it going to be like a PDF that you just put up on your website of like, hey, here's all the trash pickup zones? And then, is the map's purpose in life to reveal unknowns? Or is it being used by like NASA scientists to explore, like the effects of wildfires on the landscape using satellite imagery? That would be kind of more on the exploratory side. Or is it like presenting knowns like, hey, here's where the fires were on the landscape, and you're putting that out to like the press or residents. So these sort of like different dimensions of the cartographic cube can inform our map design. And again, this is something that's going to be talked about throughout this whole class, just introducing it in this module. Thank you.